Hey everybody, my name is Pete Barnett and I'm super excited to be talking here today at the Real-Time Data Summit. Today I'm going to be speaking about delivering real-time analytics for time series data and specifically using InfluxDB 3.0, but even more broadly, just what time series data is and how it can apply to your workflow, your work stream, and how you can overall just improve your processes leveraging a time series database. And so today we're going to be talking about a couple of key things. First, what is time series data? Why is it important? Where does it fit in a real-time workflow? What does time series data storage look like? And why is that important that it's a little bit different than perhaps traditional storage? The InfluxDB 3.0 approach, which is the newest edition of InfluxDB. And how do we put it all together? What does it look like when we take all these elements and make the best possible workflow for time series data and time series storage? And so with that, let's jump into it. With the primary question, what is time series data? Now, in some ways, it may seem simple, and in many ways it is, but it's great to have some key examples to really build upon that. And so time series data can best be described as any data where what happened in the past and what's currently happening are both very critical components and also help imply what may happen in the future. You can think of sensor data, which are very common in manufacturing plants or even in perhaps a smartwatch, where you have your heart rate sensor ongoing. You are tracking consistently over time how your fitness is progressing, perhaps your blood oxygen levels. Very key points of data which have been tracked in the past at regular intervals and also imply what may be going on or what may happen in the future. This is also very key for digital world instrumentation, your observability, knowing exactly what your CPU's processing is doing at any given moment is very critical for knowing how your computer is performing. And that's a great example of time series data. Now, time series data oftentimes comes in two key forms. The first is metrics. Now, metrics are data points that are gathered over a period of time, and these are gathered at regular intervals, perhaps every second or every 2 seconds. You can think if you open up your activity monitor on Mac, or maybe your task manager on Windows, you can look at your CPU's processing, and you'll be able to see a graph that updates consistently at a regular interval. This is what's called a metric, and this type of data is ordered chronologically, helping to understand how things have changed over time and where they're going as well. Now, the second piece is going to be events as time series data. Now, events are collections of data points that are gathered at irregular intervals, and oftentimes they're caused by specific triggers. Perhaps you have a spike in your CPU usage, and therefore that's going to cause an event that's going to be logged. Or maybe you have an abnormal heart rate, right? Again, another great example of having something that's actually triggered that's not consistently pulled, but rather instead happens at an irregular interval. So both metrics and events help define what time series data is. And from there, we can understand why time series data is important. Because again, it's going to provide a clearer picture of what happened in the past and currently what is happening to help predict what's going on in the future. For example, for weather patterns and hurricane model predictions. Being able to look at what happened with previous hurricanes and how they adapted over time and the paths they took can help imply what may happen with future hurricanes. Or take, for example, the stock market. Being able to recognize at consistent, regular intervals how a stock has changed throughout the day, or perhaps leveraging events when big major sales or buys and purchases go through, that can imply what may happen in the future or how it will be impacted going forward. These are all critical reasons why time series data is not just all around us, but so very important in how it's being used as well. Now, I want to talk about how this data is stored, because it's really critical to recognize that if you store it differently and separately than perhaps a traditional storage model, you can really unlock a ton of potential from time series data. Now, a traditional storage solution you may be thinking of, for example, is a standard RDBMS, a row-based storage system, which are great for online transaction processing. These solutions, oftentimes you can think of as in tables, and really come to mind with row-based entries. So if you want all the information on perhaps a specific transaction, you can easily get that data and not have to worry about all the other pieces of data that are throughout that data sheet itself. There's other types of traditional storage models as well that have also come in, right? Which, for example, may be document storage, vectors, which have really grown over the past couple of years, especially graph, key value storage, and so much more. And these traditional storage solutions are great for so many different reasons. But they do have some trade-offs that ultimately become challenges for time series databases. For starters, they're not great for analytical queries where you really want to aggregate data across an entire data set. And so let's take a look at the example here, where perhaps we want to understand all the temperature values for a specific data set. In this example, we're going to have to process all those rows and all those columns to grab that temperature data. And from that, we're going to have to toss out a lot of data that had already been processed. This is incredibly inefficient. It makes it very difficult to get anywhere close to real-time performance when you're trying to aggregate this data, analyze, and process it for an analytical query. We believe that there's a better way to actually solve and approach this problem, and many time series databases have also taken this adjustment. And that comes in really an architectural rethinking of how time series data is stored. And rather being stored in a row-based system, it's instead going to be stored in columns. And columns are great because they allow you to select specific types of data or measurements and quickly analyze them across your entire data set or a subset thereof without having to even look at the rest. And this is great for what's called OLAP, or online analytical processing, where data is logically organized in these types of slices. So if we were to take a look again at our previous example, if we're looking at just temperature in this scenario, we're not having to query all the rows themselves. Instead, we say, just give me one column. It dramatically cuts the amount of time it takes, not just to analyze, but process as well, because we never look at air quality or cloud coverage or other columns that don't really add value to the analytical query we need. Instead, we're just looking at one specific column. And this is a huge benefit for getting to that real-time performance, because oftentimes when you're trying to aggregate data across a large data set, really understanding what happened perhaps in the past, understanding where you currently are and where you want to go, that long time frame horizon becomes very important to have an efficient way to get to the data you're looking for. So the best practices in use, because again, RDBMSs and row-based storage are very critical to our infrastructure and your data stack. The best way to think about it is, again, really, are you leveraging that transaction processing or analytical processing? If a single column or a measurement is the most important, for example, what's my average CPU usage the last 100 days? A columnar database is going to be much better for quickly getting to that data you're looking for. Whereas if you're looking for a specific entry and you want to know all the measurements for that specific entry, that's going to be great for a row-based data system. And we would highly encourage to continue leveraging your standard RDBMS or other type of database for those types of queries. Now, I want to talk about how InfluxDB 3.0 really builds from that. So InfluxDB 3.0 is the newest edition of InfluxData's database, where a time series company focused on building the best, most performant time series database possible, in addition to other pieces that we've been working on as well. And so for InfluxDB 3.0, we had a re-architecture of this to really try to get to real-time performance. How do you get to the absolute edge of data? How do you get to the newest data being accessed as soon as it's available? Now, if we were to take a look at how real-time can pose some problems, for many queries, a standard database model just doesn't work quite as well. Now, this is a dramatically simplified ingestion module and querying example here. But standardly, you're going to have data that comes in through an ingester, is analyzed, processed, transformed, and then ultimately sent to storage, where a querier would then go to that storage, unpack it, process it, and spit it back out, which works for many scenarios very well, but it's not great for getting to real-time data. So how do we get there? One of the biggest adjustments we made specifically with InfluxDB 3.0 is leveraging querying from the ingester itself, where we're actually storing data in memory, of course, built on Apache and using Apache Arrow for direct querying. And so we're going to be able to pull that data before it ever even gets to storage. Now, over time, of course, the ingester will persist that data to a long-term storage format, for example, Apache Parquet, and it'll stand there as well. But if you want to get to that real-time performance, where seconds is just too long, where you want to get into sub-second, sub 100 millisecond levels of performance. You need a new approach. And the great thing about leveraging Apache Arrow and pulling directly from the ingester is you're not only getting the benefits of an in-memory database, in-memory storage, but you're also getting the benefits of a columnar database to do this analytical, fast, real-time processing. It's a great way to get closer to real-time. It's how we've been really able to turn that lever and turn that corner for InfluxDB's 3.0 approach to real-time processing. And now one of the building blocks upon that is interoperability. Because columnar databases are tremendous for analytics, but these need to work well in harmony with so many other solutions. For example, if you want to do that analytics using Python, probably trying to use something like Pandas, or maybe you're using Polars or other types of databases are in your data stack. Having a framework that is simple and easy to use in a common format is so very critical. And so, for example, in 3.0, we leverage the Parquet format in addition to the Apache Arrow, which both ensure that across so many different systems, you have an easy way to share your data, interact with it with different formats and different abilities as a whole. And whether you're using a large frame data warehouse, or if you're just using different tools to actually access that data, it's going to be much easier to do using the FDAP stack. Now, one of the things that builds upon this, and a question people often have, is how do you sort of work with a columnar database? Is that a lot different than a row-based format? And in the past, there have been some pieces that have tried to work through that in complicated ways, and we've really looked at how to simplify that. The first way is with native SQL, which is now built in for InfluxDB 3.0. So there's no change to how you approach the data itself from a user experience perspective. You're still able to easily query data just as you would any other type of platform and database. But in addition to that, one of the other SQL-like languages that we've been a huge proponent of is InfluxQL, which actually simplifies a lot of the time series database connection points. And so you can really easily connect with that data in a little bit faster of a way that perhaps isn't possible with native SQL. And so by bringing native SQL to InfluxDB 3.0, for example, it's a lot lower barrier to entry, easily able to interact with that. Of course, building upon that with InfluxQL for even more seamless and faster queries just makes the entire process much more seamless from start to finish, leveraging a time series database. And so how do we put this all together, right? Where does all these different pieces, where do they fit within your data stack? Well, there's a couple of key things to think about. First of all, again, performance for analytical queries is a huge performance improvement by orders of magnitude with columnar storage. And so by leveraging columnar storage within your data solution, actually leveraging the ability to have lower storage costs, you're going to get dramatic improvements over what perhaps a row-based storage system would be able to do. For, again, those analytical queries, you're going to see up to 200x, 500, almost 800 times improvements over different technologies which maybe aren't perhaps specifically built for a time series database solution and don't necessarily have that analytical querying capabilities. This is where it's really going to start to come together and having not just a very performant framework and database, but it's also going to have a tremendous, easily accessible user experience due to its built-in native SQL opportunities and also your ability to get against that real-time performance, which is so critical when you're assessing how this actually plays into your data stack. And then again, it's all about improving real-time data workflows. Used within a data stack as a specific piece, columnar storage can enable that real-time performance for your analytics and also bring great harmony and balance to your other storage solutions. There are so many great reasons to continue using row-based storage solutions. Document databases have a lot of value as well, and vector databases are huge, especially in the machine learning areas. And so columnar storage and columnar databases provide a great solution for your time series data. They're phenomenal when you're trying to do analytics on that real-time data as well. And by putting all these pieces together, you can have that sub-second or even lower response times that you need for that data you need as a key part of your real-time data workflow. Happy to answer any questions. And my name is Pete Barnett. I work in product at InfluxData. Really excited to, again, have had the opportunity to talk briefly about these specific topics and really hope that you've had a good opportunity to learn a lot about real-time data and how it can maybe be part of your workflow as well. Thank you.